from W department final year. My subject is VLSI design. First, my title is CMOS logic gates and other complex gates. General logic circuit. Any Boolean logic function have two possible values, either logic 0 or logic 1 for same input combinations f equal to 1 for all either inputs combinations f equal to 0. So in general any Boolean logic function can be realized using a structure as shown in the figure. Switch S1 is closed. S1 is closed. Switch S2 is open. Input combinations that produces F is equal to 1. The switch S1 is open. Switch S is equal to closed. Input combinations that produces F equal to 1. The switch S1 is open. Switch S2 is open for input combinations that produces F equal to 0. Thus the input and either connected VDD or the ground where the logic 0 is represented by the ground and logic 1 and represented by VDD. So requirement of digital logic design is to implement the full up switch S1 and the pull down switch S2. CMOS static logic. The generalized CMOS logic circuit consists of two transistor nets of NMOS and PMOS. The PMOS transistor net is connected between the power supply and the logic gate output called is pull-up network when where it's NMOS transistor net connected between the output and ground called as pull down network depending on getting an applied input logic the PUN connects the output node to VDD and VDD and the PDN connects the output node to the ground. The figure shown below VDD and PUN PDN we output to C load inputs and input loads. So calculated the transistor reactive for loads and with important forward decisions. Design full down network VDN by realizing and product terms using the series connected on MOSFETs or some terms using the parallel connected MOSFETs. Design the full up networks by realizing and product and terms of using parallel connected the MOSFETs or some terms of using series connected N MOSFETs are converted to the output complement the functions. Same functions are invertibly neglected such as a NOR, NAND and NOR gates not need inverter at the output terminal. CMOS inverter is the simplest logic circuit that uses the NMOS and open PMOS transistors. NMOS are used in PDN and the PMOS is used in PUN shown in the figure. In the second point, we will VDD and PMOS and V output and V input. PMOS VDSS working operation when the input and VN and high logic and the M1 transistor is on the PMOS transistor of the thus the output Y is pulled down on ground logic 0 since it is connected to the ground but not the source VDD. When the input VNN is logic low, then NMOS transistor is off and the PMOS transistor is on. Thus, the output Y is pulled up and VDD logic is instead connected source via PMOS but not to ground. In the diagram shown below, VDD and VCC and VAACS. CMOS and NAND gate. The two input NAND functions is expressed by YAB. Step 1 take completed and Y equal to AB design and PDN. In this case, there is only one NAND terms of there will be two N MOSFETs and series showing below figure. Step 3 design and contributions of P MOSFETs in parallel as shown in figure A and B. B pull up network comparing PM MOSFETs, pull down networks comparing N MOSFETs. Finally, join up fun and PDN showing the figure which realizing two input NAND gate and node we have to realize it by Y rather and Y key because of inversion of automatically provided by nature of the CMY circuit operation. AABBC VDVDMM2 working operation. One of the least one of the inputs and low of the corresponding PM voice transistor will be conducted while corresponding NM voice transistor of turn off subsequency of output voltage is high current of convenient of marginalizations. Uh, Conversely, if both of inputs are simulation high, then both PM voice transistors will turn off and the output voltage will be parallel low on two conducting NM voice transistors. CM voice NOR gate. Their two input NOR factors are expressed by Y equal to plus A. Step 1, take complement of Y equal to A plus B equal to A plus B. Design the PDN of the case of this only over on terms of MOSFETs completed with parallel as shown in the figure. Design the pun will be P MOSFETs in the series as shown figure in terms of contributions. It shown with the figure on contributions at surely diagrams. Full low network comparing M MOSFETs P MOSFET, M MOSFET, N MOSFETs or P MOSFETs are slowly done or comparing and outsides it contributing conversions. Finally, the join and PDN shown figure which relays to input to NAND and gate. Note that have realized by what and another contributing shown to provided by nature PM voice technician operation. So thank you for this wonderful opportunity. Video making by Balayogi, 2B department.